mathematicians. Today's lesson is on volume of prisms and pyramids. So we went over surface area of prisms and pyramids. You'll be happy to know that volume is much easier. It's a much simpler formula. So when you're trying to find the volume, first we'll start with a prism. Okay, the generic formula is you take the area of the base and then you multiply it by the height. I like to think of this as like a stack of quarters. So this is going to make a different shape, but it's going to be similar in thinking for volume. So let's say you have a quarter, which is just a circular disc, right? And that's worth 25 cents. So if you have one, it's worth 25 cents. But let's make a stack of quarters. So you're just stacking them on top of each other. And eventually what you get is a cylinder because you've got a stack of quarters. And each quarter is worth 25 cents. So as you keep on putting quarters on top, you're adding 25 cents more to the worth of that cylinder. Okay, so you can think of a prism and the volume of a prism the same way. So take example one here. We've got a rectangular prism whose base, and let's just highlight that in green, the base is a rectangle, and the area of that rectangle would be 2 times 6, or length times width, right? Which is 12. So imagine now you have all of these rectangles, but they're stacked up. They keep stacking up until they fill up this whole rectangular prism. And what you would do to see how many rectangles you had to stack up to make that prism, you would multiply that by the height, because that's the amount of rectangles that you used. Okay, so circling back now, in general, to find the area of any prism, it's just the area of the base times the height. And the base can change, so that's why it's a generic formula. We could have a triangular prism. We could have a trapezoidal prism. It could be a pentagon prism. So it all depends on what shape the base is, because the formula for the area of that shape is going to change. Okay, so that's why we use a big capital B. You recognize in formulas, a lot of times when you see a capital letter, that usually means that there's a separate formula kind of within what you're looking at. Okay, so then in this case, the big B means that it's the base. So you have to look further into the problem. That's why it's really important when we make variables that we are sure to recognize lowercase and uppercase and treat them differently. So let's look at this first one here. We know that the volume is equal to the area of the base times the height. And I'm given all the information I need. So we said previously that the base, which is a rectangle, is length times width. So when I break this down into a rectangle, I get length times width. And then I multiply that by the height. And now, since I know all of these numbers, all I have to do is substitute the numbers in there. So the length is going to be 6. The width is going to be 2. And the height is going to be 3. And 6 times 2 is 12. 12 times 3 is 36. So we have 36 And now this part's important too. When we talk about volume, okay, that means we're doing cubed, okay? So we have this length in meters, this length in meters, this length in meters. Since we have 3 meters that we're multiplying together, okay, that means it's 36 meters cubed. So that would be the final answer. 36 meters cubed would be the volume of that prism. Moving on to the next one. Similar problem, right? We still have the volume of a prism, but it's not a rectangular prism. In this case, it's a triangular prism. So our generic formula doesn't change. We're still doing the area of the base times the height. But in this case, the formula for the area of the triangle that we're looking at would be 1/2 the base of the triangle, so that's a lowercase b, times the height of that triangle, so lowercase h. And we're multiplying that by the height of the larger prism. And now we know what these numbers are, so we're going to substitute in. Volume equals 1/2. The base of the triangle is 4 millimeters, so I'll put in 4. The height of the triangle is 6 millimeters, so I'll put in 6. And the height of our larger figure is 5 millimeters, so I put in 5. And now I multiply this out. 1/2 times 4 is 2, times 6 is 12, and then 12 times 5 gives you 60. And again, if I'm looking at my units, I've got millimeters, 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 so that's 3 times. That means that it's millimeters cubed. So my final answer is going to be 60 millimeters cubed. It's very important that you use cubed as your dimensions. That way people know that you're talking about a unit of volume. So it's a 3-dimensional figure. The next shape we're talking about is a pyramid. So the volume of a pyramid can be found by seeing how many pyramids fit into a rectangular prism. So if you take a look at these pyramids here, we've got this yellow one, this green one, and this blue one. If you put those together, okay, those are 3 of the identical pyramids. If you put them together, they create a cube. That means that 1 cube is equal to 3 pyramids. If I wanted to say, well, what does 1 pyramid equal? What's the volume of 1 pyramid? Well, it's only 1/3 of the volume of a prism, which we just found out was the area of the base times the height. And remember, the base can change depending on what the shape is. So let's scroll down now and take a look at some of these pyramids. So here it looks like we have a rectangular pyramid. That means the area of the base is a rectangle. So my volume, which starts out as 1/3 times the area of the base times the height. And I know that the base in this case is a rectangle. So it's a length and a width. So my formula changes to be 1/3 times the length times the width, right? That's what the B stands for, and then times the height. And I keep going with these numbers, so that's 1/3. The length in this case is 6. The width is 2. And the height, it says, is 3. When I multiply all those together, 1/3 times 6 is 2. 2 times 2 is 4. And 4 times 3 is 12. So this is 12. And then we've got meters cubed because of the 3 m's, the 3 meters that we're multiplying together. Your goal is to do part B on your own. And when you're done with that, show your teacher, and then you can move on to the last example before the practice. All right, now that you've done that problem, we're going to move on to the last example. So we've got 2 bottles of lotion here. They're both in pyramids, but they're different shapes. So we're going to see how many times how many times more lotion is in bottle B than in bottle A. Okay, because bottle B is more expensive, so we would expect to get more lotion out of it. So let's take a look. We'll split it up. We'll do bottle A on the left and B on the right. Both of these are going to be using the same formula of volume equals 1/3 base times the height. And with problems like this, you can either do all of bottle A first and then all of bottle B first, or you can kind of go each step with both bottles at once. I'm going to show you how to do that because typically what I do is I just do bottle A and then bottle B. I'm going to show you a different kind of way to approach it. So both of these bottles have a base that's a rectangle. So that means that we're going to be splitting this up into a length and a width. And of course, we multiply that by the height. And because it is a pyramid, it's always 1/3 of the volume of what it would be if it was a prism. And now we're going to put in the numbers for each of the bottles. So for bottle A, we've got 1/3, and then the length of that base. So let's go in and highlight the base here. The length is going to be 4, and the width is going to be 3. Now, if you do the length is 3 and the width is 4, you can do that as well. It doesn't matter which way you approach it. And the height for that one says that it's 15. Bottle B, we have volume equals 1/3, and the length for that one is going to be 6. The width is going to be 5, and the height is going to be 10. Then we do our multiplication. So we have 1/3 times 4 times 3 times 15. That gives us 60, and it's centimeters, so we say centimeters cubed. for bottle B, we get 1/3 times 6 times 5 times 10, which would be 100, and it's centimeters cubed. Now let's ask kind of a separate question here. Which is the better purchase? Because ultimately, I mean, I don't know about you, but ultimately for me, I don't care what the bottle looks like. I want to know that I'm getting a good deal. So let's take a look. For bottle A, again, we can still separate this. For bottle A and bottle B, the volume for A is 60 centimeters cubed, and the cost is $6.60. So let's make a ratio. Let's say the ratio is going to be the cost per centimeter cubed. So that means that for bottle A, it's 6.60 over 60. And for bottle B, it's 10 over 100. And when we reduce those, it means that for bottle A, it's about 11 cents per 1 centimeter cubed. So all I'm doing is I'm doing 6.60 divided by 60. You get 0.11. And then for bottle B, if we do 10 over 100, we get 0.10 per centimeter cubed. So which one costs less? Okay, which do you get more of? And it looks like per centimeter cubed, it's going to be bottle B. So even though it's more money and it's a different shape, you actually get more product from it than you do with the other one. So that's somehow sometimes companies do that. They make their bottles look funny so that you can't notice that there's less product in it. One example of that would be a bag of chips. If you think of a bag of chips, it's mostly air. They want you to think that there's a lot of chips in there, right? The volume of the chips is much different than the volume of the bag. Okay, so that's just one way that companies use the dimensions of their products to their advantage. And once you're done and you've gotten that part B of that pyramid example checked by your teacher, you can move on to the practice problems.